this session, we are going to discuss about course objectives, course outcomes, and then syllabus. Here the course is nothing but problem solving and computer programming using C. What are the objectives? What are the objectives of a course? So objectives are generally written from the teacher perspective. Now why the teacher is actually teaching the subject? What is the purpose? What is the purpose? So they are considered as objectives. As course outcomes. Course outcomes are written from student perspective. Now why you are writing the outcomes means what the student is going to achieve. What the student is going to achieve. What is the net result of studying a subject? Objectives means why somebody has to study the subject. Outcome means what is the net result of it. What is the net result of it? There will be always a mapping between objectives and outcomes. One or more objectives will map to one or more outcomes, and one or more outcomes will also map to one or more objectives. So there will be a mapping. There will be a mapping. There will be no isolated objective or isolated outcome. No isolated objective, no isolated outcome. So after that, we are going to discuss the syllabus, how this course is actually organized. So coming to the course objectives, the first one is discuss how the computing has evolved over the years and the future of computing. Now, how the computing has evolved according to you? Can you guess? Can you guess? In good olden days, how people used to count at least. So people started counting using what are called as pebbles. Pebbles. So using pebbles, people started counting. So after that, maybe the calculators came into picture, abacus came into picture, and then the computers, mainframe computers. After that, personal computers. Now we have supercomputers are also personal computers which are having the capacity comparable to the supercomputers of 20 years back. So our personal computers, including our cell phones, are very, very powerful nowadays. You can do a lot of things with your cell phone. The only problem with the cell phone being the size of the screen. So how the computing has evolved and in what direction we are moving. So we have basically what are called as quantum computing and molecular computing. We are moving towards quantum computers and then molecular computers. These are the two types of computers which can materialize in the future. Quantum computers are expected to solve many of the limitations of today. Many of the limitations of today will be solved by the quantum computers. And molecular computers is a radical change using the water molecules to do computing. Remember, water molecules have the capacity to remember. That's the principle that is actually used in homeopathy. The water molecules have the capacity to remember. So now how do you exploit that capacity? To do the computing? So that we are going to discuss. So that is the first objective. Let's demonstrate the internals of a computer. What exactly is the computer actually? So many people think that the monitor which they see is actually a computer. Monitor is just a display. There is nothing inside it. It is capable of only displaying. Maximum it may have the three guns called as red, green, blue, or it can be LCD display, LED display. LEDs may be present there, liquid crystals may be present there. So that is the just display device. So but main computing capability of a computer is present inside the black box which you see. If you consider a desktop computer or if you consider a laptop computer, it is inside the bottom part of a laptop. So now what are the internals of a computer? What are the parts of a computer that make the computer so powerful? So we have processor, we have what is called as main memory in the form of RAM, we have hard disk, we have DVD drives, we have DVD drives, we have motherboards, which are printed circuit boards, and many other components which make a computer. Computer is a complex one. It consists of huge number of components. Next, demonstrate the techniques for problem solving in computer science. Problem solving techniques. So we solve problems in our daily life. Now, whenever we try to solve the problems in computer science, we try to solve the problems which enable the computer to solve them. That means we should be able to implement them using a computer. So we will study different problem solving techniques in general and with respect to the computers also. We will mainly concentrate on 4 steps that are given by the Polya, a great mathematician. There are some techniques called as Polya problem solving techniques. Those things we are going to discuss. Next, I will introduce you to the syntax and semantics of a language. Syntax is the way in which you have to write. Suppose in Telugu language, if you consider Amma, so you have to write A, Ma, and then Mavatu. So those letters you will write in some sequence, in some form. So that is nothing but a syntax. So you cannot write Ma and then A. So it is the case with all the languages. THE means you will write it as THE. You don't write H, T and E and you call it as the. So the syntax is to communicate the information properly. It's actually a kind of agreement. That is designed for convenience. And semantics. Semantics means what is the meaning? What is the meaning of it? If you write, say, A plus B, what is the meaning of A plus B? So A is one operand, B is one operand, plus is the operator, and the purpose of that operator is to add the contents of A and B. The values of A and B are to be added. So that is the meaning. That is the semantics. Next, illustrate the programming constructs of C language. So every language will have some features. So these are important. Every language will have some features. So we have to use those features of the language. So in fact, we choose the language based on features it has. So you select the problem. I try to identify the solution. After that, you select some language to implement it based on the features it contains. So the features are usually in the form of what are called as control structures, and then the data structures directly supported by that language, and the modularity that is supported by the language. There are a number of other features also, programming constructs also. We have to consider all those programming constructs, and we have to know how to use those programming constructs. Next, discuss how the data is organized and manipulated. Data is very important. In fact, we write the programs to manipulate the data. In most of the cases, we manipulate the data. Now, the data is to be organized in appropriate manner so that the manipulation is easy. Or so that you can do some calculations or computations easily. Suppose you take the telephone directory. Telephone directory is arranged in an alphabetical manner according to the name. So whenever you are asked to find that telephone number of a particular person, it is easy for you to check the number, to find the number, because you know the starting letter of the name. So you try to go to the approximately to that page. So even if you go there, it's fine. Even if you don't go there, you know whether the letter is on the left side or on the right side. So like that, you are going to search quickly. So imagine a telephone directory which is not organized or which is not sorted according to the name, but you are still asked to find out the number. It's a complex task. So data organization influences the solution complexity or algorithm complexity. So it influences the solution complexity. So the solution which you are going to use depends on how the data is organized. If you choose wrong data organization, your solution becomes complex. So we'll discuss algorithms and how to convert the algorithms into program. Algorithm is nothing but a sequence of steps to be followed. Okay, how do you write the algorithm? How do you write the algorithm? How do you convert that algorithm into a program? So definitely this algorithm is language independent. Language independent. That's why you write algorithms first. So after that, you have to implement it. You have to make the computer run that one. For that, you have to write the program. So you should be able to convert the algorithm to programs. How do you convert? We'll discuss. We'll also discuss the different possible solutions to a problem. We don't discuss the specific solutions to specific problems, but the point to be noted here is every problem will have actually multiple solutions. There will be many solutions that may be possible. So we have to consider all the possible solutions and choose the best one among them. So that we are going to discuss. And then solve real life problems using computational approach. We'll consider some examples of real life problems and we'll see how to solve them using the computational approach. And we'll also discuss the limitations of computing. So you cannot solve all the problems using computers. Now, can you improve the face value of a person using a computer? No, you cannot. You cannot improve the face value. Maybe you can do some makeup, but you cannot improve the face value permanently. Okay. So you cannot do all the things using computers. So what are the limitations and why these limitations? Why these limitations and how we are using those limitations for our advantage? That's very, very important. That's very, very important. In the security field, many of the advantages are we are able to provide the security because of the limitations of the resources, including the computers that are available nowadays. So the security features, security algorithms or security solutions which are available today may not be valid after 10 years. Please note that point. Next, coming to the course outcomes. So these are written from student perspective. Student perspective. So what is the net result of studying this subject? So the first one is you will be able to explain the working of a computer. If somebody asks you, maybe in your family, maybe outsider, how the computer works, you will be able to tell them. You will exactly know how the computer works. Now, why you have to know how the computer works? You can provide effective solutions. You can provide effective solutions using computers if you know how computer actually works. Whenever you try to write large programs, you try to exploit the features of a computer. So we'll discuss the working of a computer. You will be able to demonstrate to the others. You will be able to divide the problem into sub-problems. So when the problem is simple, you will solve it directly. When the problem is complex, you cannot solve it directly. You will divide it into parts, or you will divide a problem into sub-problems. So after dividing, you can solve it. After dividing, you can solve it. And apply different problem solving techniques. What are the problem solving techniques that are available? And depending on the problem, you have to apply appropriate problem solving technique. Understand the syntax and semantics of C language. You will be able to understand the syntax and semantics, or you know the syntax and semantics, and you are going to write the programs according to proper syntax and semantics. Next, select different features of C language based on problem to be solved. So this is very, very important point. So select different features of the C language based on the problem to be solved. So you cannot use all the features of the language to solve all the problems. So you have to choose appropriate feature of the language. Appropriate feature of the language depending on the problem to be solved. So it depends on the problem. So you have to choose appropriate features. Then if you select appropriate features, then your solution becomes simple. Otherwise it becomes complex. Evaluate already written code. Already written code means maybe the code written by somebody else. Maybe the code written by somebody else. Why you have to understand? Why you have to understand? Because you cannot solve the problem on your own. Usually work in a team. So you have to understand the other's code also. And also the code will be maintained for some years, 10 years, 20 years, sometimes 100 years also. So in that case, you should be able to understand that code and maintain it. Maintain it means you should be able to make modifications to it, enhance the functionality. Modify the code to improve it. So you have to improve the code and then convert algorithms to programs. You should be able to do it. You will be able to do it. Design C programming solutions for real life problems. So you will be able to provide solutions. So coming back to the syllabus. What is that we are going to study? We will divide this course into modules. In fact, 13 modules. 13 modules will be there. So we'll be dividing the course into those modules and we'll discuss all those modules. You may follow all the modules in sequence. Or depending on your previous knowledge, you may skip some modules also. That is also, I'm going to tell you which modules you have to concentrate, and depending on your interest, you may skip a few modules. But the recommended one is you follow all the modules in sequence. So first one is Introduction to Engineering. We will study what is engineering actually. Why you are called as engineer? So what is meaning of engineering? What are the different disciplines of engineering and how they are differ? And how or why the different engineering fields, programming is being used. Why we should study programming? Why civil student, mechanical student has to study programming? What is the importance of it? So that we are going to discuss in the first module, Introduction to Engineering. Next, Introduction to Computer Science. How computer science is different from other disciplines, and what is the thinking that is required? For solving computational problems? Certain psychological aspects are required. So you should orient your mind in such a manner so that you can solve the computational problems. So what are those psychological issues which you have to consider, or psychological abilities which you have to develop? That we are going to discuss. So all these things are applicable even for other courses also. So if you develop those things, you will be comfortable with this course and also any other course related to the computer science. Problem solving. We discuss Polia's problem solving techniques here, and how do you solve the problems? What are the problems which you have to consider? We will classify the problems also. So problems which can be solved, problems which cannot be solved by computers. Programming methodology, abstractions and paradigms. You can solve a problem in different ways. Methodology, abstractions. How do you solve it? Abstraction is a basic principle that you use in our daily life to solve the problems. Abstraction is the basic principle which we use in our daily life to solve the problems. So it is used in computer science also, and it is used in other branches also, though we may not realize it. As a child also used principle of abstraction. So abstraction is actually taking the essential characteristics for the time being and neglecting the other things, only for the time being. So whenever the problem is complex, you cannot handle it as a unit. So you divide it into parts, you arrive at different levels of abstraction, and those low levels of abstraction are solved, or solutions to those abstractions are found. After that, you try to combine them, integrate them. So abstraction is the major principle. So that we are going to discuss, and paradigms. Okay, we are discussing C language. We are discussing C language. We are using C language. So C language is procedure-oriented language. So that means we concentrate on the procedures to be used to solve the problem or individual subproblems and then combine it. What are the procedures that are to be used, or what are the procedure that has to be used to solve the problem? But there are other ways of solving the problems also. Object-oriented programming paradigm is there, event-driven programming, logic programming, and then functional programming, etc. So these different programming paradigms you will study in the coming years. That whenever you study other programming languages, maybe usually you study the language based on other programming paradigms other than this procedure-oriented programming. But anyhow, what are these programming paradigms and what are the advantages of it? So it gives you a broad view. So it gives a broad view of all the languages that are available. So as a computer science professional, so you are expected to learn at least 4 languages. And don't say that somebody has to teach you. It's not the case. You should become a self-learner. You should be able to learn the language on your own. There are a number of resources that are available nowadays. MOOC courses are available. Online courses are available, which you can do. So I will introduce you to the C language in the module Introduction to C language. What are the characters of the C language? What are the characters of a C language? What are the operators? What are the operators of C language? How do you write these operands, etc. All those things we'll study in the module 5. Programming constructs. What are the features, control structures that are available? Maybe the data structures that are directly supported by the language. So those things we will study as part of the programming constructs of C language. What are the programming environments that are available also, we are going to discuss there. And then the control structures, we will go into the details of control structures in the control structures module. So control structures means those structures or those statements. You can say instead of structures, you can use the statement, the word statements. So control statement is one which allows you to control other statements. There will be a number of statements. You have to control the execution of statements. Maybe you want to execute the statements one after the other. Fine. So maybe if some condition is true, you want to execute this one. If some condition is not true, you don't want to execute something. Or you want to execute these things repeatedly. You want to execute some set of statements repeatedly. So there will be some support from the language. What is that support provided by C language? That we are going to discuss as part of control structures. And arrays, how do you arrange the elements? Array refers to the actually homogeneous collection of elements. What is the meaning of a collection? Why do you arrange the elements? In a specific form? Maybe one after the other, or the different elements are distributed throughout memory. So why we have to arrange the elements, and by arranging the elements, what are the operations which you can do easily? That we'll study as part of the module arrays. And then functions. So you will be dividing the problem into subproblems, or you will be dividing the solution into different solutions. So every problem will have a solution. Every subproblem will also have a solution. So all this will be represented using what are called as functions, or it is part of the more general concept called as modularity. What is modularity and why do you use it? We'll study as part of the functions. And then pointers, which is highly efficient and effective feature of the C language, but it also has its own limitations. So if you are not careful, you can crash your system. You can write a program which crashes your entire system. That you can do using pointers. So it's very powerful feature, something like a knife. Knife you can use to cut vegetables, or you can cut the neck of a person also. So whenever any tool is powerful, we should carefully use it. So we are going to discuss how to use pointers. And then structures and unions. So again, arranging the different elements. Suppose you are a student. Now, what are the attributes? What are the attributes of you, or those things which describe you? So you will have a roll number, you will have a name, address, class, branch, maybe attendance particulars, marks, etc. So all those things you should be able to group. So that grouping is done in structures and unions. Your grouping is done in arrays also. In case of arrays, it is homogeneous collection. In case of structures, it is structures and unions, it is heterogeneous collection. So we'll discuss how to represent the data using structures and unions and how to manipulate the data. And then the files. So finally, everything will be in the form of files. So the C program which you are going to write, it is called as source program, and it is present in the file. So the audio, you have different MP3 songs. So where they are stored in the form of files, and then video is also stored in the form of files. So everything in an operating system is in the form of the files. In the computer, everything is stored in the form of a file. So we'll discuss how to create the files, open the files, read the content, write the content from the files as part of these modules. And we'll discuss some advanced features. Basically, we'll try to combine the other features and then discuss how to use those features. Also, some features which we are not which doesn't fit in the above modules, those things we will discuss as part of the some advanced features module. So this is the syllabus. So we discuss in this module, we discuss course objectives, course outcomes, and then the syllabus. Course objectives, course outcomes, and then syllabus. Have a nice day.